far we discussed in the last class, we discussed sampling and sampling distribution and confidence intervals. Today we will have two sessions about study design. Hopefully I can present it so that you understand. Please ask if you don't understand something. Just to remind you about last sessions, sampling and confidence intervals. And for the students who are new, maybe, who didn't attend the last class, we have spoken about sampling, which meant that we have a population of n people, and from the population we take a sample which we refer to with the small n. And two issues we said are important in sampling. One is the sample size. How many people we should take from the sample. It should be representative. And there are ways to calculate, formula to calculate the sample size, how many people we need, because depending on your study design, depending on what kind of analysis you are going to do, depending on the size of the population, your sample size will also change. So it should be representative. Then what's the method of sampling? Sampling method. In which methods we mentioned, do you remember? Can the students help me to count the methods of sampling? The most important one was what? Random, simple, or simple random. Simple random. Simple random sampling, which means either you use random numbers or the computer, or use the dice or some random method to select, to decide which individuals from your population are going to be sampled. What else did we mention? Can I ask opinions, answers, take answers from the students? Adil, Berkay, are you there? Adil? What else did you mention?
Yes, teacher, I am here.
Yeah. Have you attended the last session? Quota sampling, do you remember? We had the quota sampling.
I remember, but
What else did we have? We have spoken of snowball method sampling. Quota mostly used in polls, as you hopefully remember. Snowball used mainly for difficult access groups. With difficult access. Marginal groups or minorities. Then we mentioned of square root. We mentioned stratified sampling. And I said there may be other methods, but for you, for this class, important is that you memorize. We have, we need a representative sample, and it should be whenever possible. We mentioned also about the convenience sampling, of course. Convenience sampling. Important is that you make it random. Whenever possible, we should have a random sample. By sampling, we introduce an error. There is a mean of the population here, the mean, and standard variance or standard deviation of the population, which is not exactly the same when we take the sample. The sample of the mean shown by X bar, and the standard deviation, they are not exactly the same. They may differ a little bit depending on your sample size and also the method of your sampling. So there was a way to calculate this error of sampling. Do you remember what it was? What we called this parameter? It was the standard error of the mean. What was the formula to calculate the standard error of the mean?
S/√n.
Standard deviation, S or SD, yes. Standard deviation, we call it also standard deviation, S or SD, divided by square root n. This was our formula to calculate the error we introduce by sampling. And if you are calculating, if you are dealing not with a mean but a proportion, then there was the standard error of the proportion. And the formula for this was square root P multiplied by 1 minus P, the probability, multiplied by 1 minus probability divided by. Okay. So far, this was a repetition just to help you to memorize what we learned. And sorry, we also discussed, of course, the confidence intervals. And this was the mean. The mean was a point estimate. It's a point estimate. We have also interval estimate, which is the confidence interval. Confidence interval is an interval estimate. Because we are not 100% sure what we calculated, we should, whenever possible, give the confidence interval. And usually, we choose to give the 95% confidence interval. What was the formula for the 95% confidence interval?
Point estimate plus minus 1.96 times standard deviation.
Thank you, Beyzanur. Yes, the point estimate, the mean, plus minus 1.96 or 2 multiplied by the standard error of the mean. This was our formula. And why we have taken 1.96? Because if this is, of course, if the distribution is normal, the distribution is normal, is symmetrical or normal. If it is symmetrical, as it is in this histogram shown in this graph, we know that 95% of our 95% of our cases are distributed in between plus and minus 1.96 st and plus 1.96 st. In between the mean plus minus 1.96 st. We have 95% of the cases. Therefore, we use this 1.96 here. If you are dealing with 99% confidence interval, then 99% confidence interval, the formula would be a little bit different. You may guess, if you remember the class, the course instruction about the normal distribution. Do you remember?
Yes, it was 2.58.
Thank you. 2.58. MashaAllah. Yes. Standard error of the mean. So if you want to calculate, and all these three formula, the standard error of the mean and the variance and the confidence interval, you should remember for the exams. Although all this is done by the computer today, still I believe that the students should know the basic calculations. Yes, now it's time to discuss about study design. The study design is vitally important. I will read some quotes from the book for you, because if you have very large amount of data, but you have made a poor study design, it will be, if you don't have a good sample size selection, it will be wasting of your resources. So we should know about the study designs and how to conduct a good study. Here in the book, in this page, we have some study designs, some names of the study designs, which I believe they are important, and you should know them. Okay. They are either, a study can be either experimental or observational. So first of all, you should classify study experimental or observational. Let me write it in this whiteboard here. I realize study designs, studies, or research, we call it, equal to research. We call it, or investigations. Investigations. So they can be experimental studies, or observational studies. We have experimental or observational studies. In the next classes, I will mention about the clinical trials, which is an experimental study type, and then in detail we will go through the cohort and case control studies. But here we will just briefly mention what they are and what are the differences of these different study types. Experimental, and the other type is the observational study type. Design, observational study. What is the advantage of having an experimental study? The main advantage, as you will read also in the book, the main advantage of an experimental study is that you can control control for the conditions. You can control the experimental conditions. You can decide what kind of atmosphere, what kind of study conditions you will have. That's the factors that may affect your outcome. You can, if you have an experimental study, you can decide for the factors of that affect the outcome. For an example, imagine an animal study where you have or rats or some other animal in the laboratory, and you want to see you want to compare the effect of a medication on diabetes. Just to make an imagine about it. Most important difference of experimental from the other studies was what? You can control factors affecting the outcome. Okay, and our example is diabetes, for example. Diabetes. Let's say blood glucose. What kind of variable was blood glucose?
Numeric.
It's a numerical variable. You want to measure the numerical variable and compare it between two groups, drug A and drug B. Which one is more effective in controlling blood glucose? So if you do this study in the population, in a population study, you give medications to the people on this who come to your office, and you conduct this as a population study, as an observational study. You cannot control the conditions, because when I say diabetes, the severity of diabetes may change, isn't it? The severity, there are diabetics who have relatively normal blood glucose, like 120 milligram deciliter, 130, 140, but there are other people who have much severe disease, who have much higher blood glucose levels. So not all my patients in the study, in an observational study, will be same. There will be differences between the groups. But if I make an experiment, I can, in the laboratory, I can have animals which have exactly the same diabetic disease. So this disease is the same. And then the living conditions are the same. In the laboratory, you have a certain humidity, certain you give certain food to the animals to eat, certain amount of drink. You can control everything. But if you do an observational study in a population, you can not force the people, or you cannot control the people, what they eat, in which conditions they live, whether they exercise or not. That's pretty much different. So an important part in experimental study, an advantage, you should know the advantages and disadvantages. The advantage is it is allowing you to control for the factors. But experimental studies are, they have some disadvantages as well. What is the disadvantage? It is not always feasible to do it. And if you do animal studies, you have ethical problems, of course, and in humans, the ethical problems are much more. So both animal and human studies, there are ethical conditions to be respected. Oops, what is this? It should be white. There are ethical conditions which you have to consider. What about the observational studies? When we say observational studies, the two important topics, types of observational studies are the cohort and the case control. So observational studies are further divided. The cohort, the case control, and we have the cross-sectional. In the table, you will find all of this, information about it. Cross-sectional studies. Cross-sectional studies can also be simple cross-sectional or repeated cross-sectional. So cross-sectional studies can be simple, one cross-sectional or simple cross-sectional, or repeated cross-sectional. Okay. What is a cross-sectional study? The name implies, as you understand from the name, a cross-sectional study means you are behind a prevalence of a condition in the population. You want to see a cross-section of the population, such as if I want to study in your class, in other two medical students, class 2, what is the proportion of people using eyeglasses? This would be a sectional study. Just I'm behind the proportion of people who are using the eyeglasses. And if I repeat this study next year, whether I want to see the trend, whether there is a change in the proportions, then it will be a repeated cross-sectional study, which is also very popular in some countries. I don't know how is it in Pakistan or Kyrgyzstan, but in Turkey, we have the example for the cross-sectional study is the TNSA, and in USA, we have the Youth Health Risk Survey, Youth Health Risk Survey in the USA. And in the Turkey, we have this TR, we have this TNSA. What was the abbreviation of TNSA? Okay, I forgot it. Sağlık araştırması, Türkiye Nüfus ve Sağlık Araştırması. Turkish research on the population and health, which is repeated every 5 years. Also, the Youth Health Risk Survey in the USA is a repeated cross-sectional study. They want to see what kind of risks the youth, the young people in the age of high school, what kind of risks they are engaged. Are they carrying weapons when they go to school? Are they using drugs? What kind of risky behaviors they have? Yeah, cohort and case control I will mention more in detail. We may also have epidemiological studies, such as which is done very frequently today, study at the nature of an epidemic or a disease, such as the pandemic, COVID-19 pandemic, which we are facing today. Yeah, the unit. What is the unit of observation? The unit of observation is most of the time the individual, an animal, a person in our studies. Most of the time, almost 100% of the time. But it is possible that you have the unit of study in an ecological study, for example, where the unit of the study is a community sometimes. Okay, so if I ask you the difference between ecological study and human study, a randomized controlled trial, it means the unit of study is different. Okay, yeah. A cross-sectional study is what you are estimate of the prevalence in a cross-sectional study. When I say cross-sectional study, the first thing coming to your mind should be the prevalence. And here is the formula for calculating the point prevalence. You just divide the number of events in a time point to the population, to the number of studied at the same time point. So the number of point prevalence in a cross-sectional study, the point prevalence is equal to number of events divided by the total population. The number of students with the eyeglasses divided by the total number of students in the class. Very much easy. Yeah, repeated cross-sectional, I said. And in some studies, we have the controls. In a cohort or in a case control, sometimes also in cross-sectional studies. In one of our earliest classes about how we ask a question, an answerable clinical question. Do you remember the
Pico format.
Sorry, PICO format. Yes, PICO. So always we look for an intervention. Always we want to, in a study, we want to see a control group. Doing a study on only one group is not good. We want always, we try to have controls. And the control group can be treatment comparisons or healthy people in the population. Lastly, I have to mention about the bias in study design. What is a bias? There are other study types, observational studies, but I remain with these three: cohort, case control, and cross-sectional. And what is bias? Bias is also very important. In a study, bias is if there is a systematic difference between the results, systematic effect, which will affect the state of affairs. Just trying to give you an examples of bias. Imagine you are measuring and your scale is wrong. You have an error with your scale, wrong scale, or you are biased with data collection. How we can introduce bias? We may have selection bias or measurement bias. By the way, I should mention about selection. We may have errors in selection, bias in selection, or bias in measurement. Okay. If I make an error in the selection of my group, selection of my people, like in an experimental study, you have the experimental group or the control group. Also in a case control study, you have the cases and the controls. So if you don't do it, make it random, but you introduce your own preference, own convenience or something, then you have a selection bias, which will, of course, affect your outcomes. And if your scale is not measuring correct, or when you're collecting the data, you, for example, in a retrospective study, file study, you need to see all the files of the patients. You don't read it truly, the files, and you miss something, or you don't understand when you read, when the researcher should be somebody with an experience. Instead of an experienced person, you give the data to a novice and he doesn't understand what's written in, and he makes errors in data collection. It means you introduced a measurement bias. Therefore, to overcome this bias, we sometimes make repeated measurements, for example. If you are not sure about your scale, whether it is measuring correctly, you're measuring height, let's say, or weight, or blood glucose, and you're not sure you have bias or not, you make two measurements and then take the mean, or even more than two measurements. Okay. And is it? I think. Yes. Shall we have a break?
10 minutes break.
Okay, let us have 10 minutes break. What time is it now?
9:37.
Okay,
AM.
so 9:47 we will be together again. I'm online, I will not turn off. I will just take a tea and come back.
Termek baca kandaş.
жақсы сізге өзіңізше.
Ben de жақсы. All down. How are you guys? How are you, friends? How are you? Faiz, how are you? كيف حالك؟
I'm good, thank you. أنت كيف حالك؟
الحمد لله خير.
Okay. May I continue
Yes.
the second session? In this session, I am going to discuss with you about variation. You already know what variation is. We have a measurement error, which is depending on a measurement or biological factors. And we can calculate actually how much error we introduced by checking the standard error. Standard error. By checking the standard error, we may calculate how much error we introduced. So this you already know, and you know that if the standard error of the mean or standard error of the proportion is high, it means we have an imprecise measurement, and we actually want to have a small standard error, small variation. We don't like variability. You don't want, whenever possible, we want to avoid variability. And here we will discuss some methods about variability. One is replication. Then we will discuss about the sample size. And I will introduce some particular study designs such as blocking, parallel and cross-section, crossover designs, and factorial experiments. And then these are the figures for the parallel and crossover. And we will discuss about the endpoint, outcome, or study and endpoint. So, what can we do? The question is, what can we do to decrease variation? What can be done? What can be done to decrease by variation? I mean what? I mean standard error of the mean or standard error of the proportion. What can be done? Because if we have a high standard error of the mean, it will indicate that we have an imprecise, non-precise measurement. One way is to have replication. One solution is replication. Not replication, replication. What is replication? Instead of making only one measurement from one person, you may replicate the measurements and make more than one measurements in the same person. And then you can take the mean 2 or 3 sometimes, mostly 2 or 3 measurements they do, and then take the mean of these measurements. That will decrease the variability a little bit. As you remember, there was a within subject and between subject variability, and within the same subject, if you make repeated measurements, there will be small differences between the measurements. And by taking the mean of these measurements, you may decrease the variability a little bit. The other solution is sample size. Why sample size? Because we know that the standard error of mean is related with the sample size. I asked in the previous class, and you said the formula was standard deviation divided by square root n. So if I increase the n, increase the the sample size, my standard error of the mean will decrease naturally. Therefore, the sample size calculation is a separate issue, and it is not under our objectives for this class how we calculate the sample size. But you should know that sample size is very important, crucial. It should be you should have enough sample size to represent your population. Okay. The other issue is you may have different study designs. So the third solution is particular study designs. Particular designs, such as blocking. I may do blocking, stratification. That's not frequently used in research. Blocking, one is blocking. Imagine you are doing a study among people who are young as well as old. You have a different range of people. If you have a different range of people, that means and you measure blood pressure, for example. Huh? My example here is blood pressure. You measure the blood pressures, the systolic blood pressure, let's say, okay, the SPP, systolic blood pressure in people aged 18 to 65. Wow, big range here. If you measure the blood pressure of young people, 18, 20, 25, 30 years of age, it will be low. If you measure the blood pressure of all elderlies, like 60, 55, 65, it will be higher. So the variability will increase. Instead of measuring it in this age group, you may divide it, you may make blocks such as 18 to 40, and then 41 to 65. So by having these two blocks, you have the opportunity, you have the possibility to decrease the variability a little bit. This is what we call blocking. Then we have parallel and crossover designs. What is that? Parallel versus crossover. Let me try to explain you what parallel and crossover design. Mostly in a research, we have parallel trials. In a parallel trial, let me show you this figure here. In a parallel trial, you have a sample from the population. You make a baseline assessment, baseline measurement, and then you give drug A. This is administered therapy, drug A. And you have a control group. You give drug B, and you assess the response. To make it easier to understand for you, our baseline assessment is again here, systolic blood pressure. Systolic blood pressure. We measure blood pressure. And we want to see whether our medication A or medication B is more effective in decreasing the systolic blood pressure. So you measure it in the beginning of the study, and then you give the medications to both groups, and you assess the response. After a few weeks, let's say 1 week, 2 weeks of therapy, you measure the blood pressure again, and you will have different mean different blood pressures between the study and control groups, of course, and you compare them. By comparing, you try to understand whether there is a significant difference between the therapy group, the drug A group or drug B group in decreasing blood pressure. This is a classical design of the classical parallel study design. But since the variability between the groups, so the variation between the groups, the therapy and control groups, these are not the same people. These are different people. And just remember, we have within subjects and between subjects variability, and the between subjects variability is naturally high. So even if you don't give drug A and drug B, you compare the two groups, there will be a difference. There is a variability between these two groups because they are not exactly, this is not a laboratory animals, these are different people. So there will be a variation. What kind of solution we may have? We may do a crossover study. Crossover, as you see, if you compare the two figures, until here, it is the same. The figure A, the first figure, is copied here. So what do? We have again a population. From the population, we take a sample, and in this sample, we make a baseline assessment. After having the baseline assessment, we measure the blood pressure, the systolic blood pressure, or anything you want to study. And then we divide the participants into two groups. One group, we give a medication A again, the therapy, and then we have a control group. We give another medication. We assess the responses. But at this stage, we don't stop our study. Instead of stopping the study, we wait for some time. This is called the washout period. We wait for some time. And why do we wait? Why do we need a washout? Because this medication should be removed from the blood. It should be shed out. After the washout period, it can be 1 day, 2 days, or 1 week, 2 weeks, depending on the type of medication you are using. Some medications remain in the body more longer than the others. After this, then you see this therapy group becomes the control group. You switch the medications. You give medication A to this group and the medication B, the therapy, to the other group. So by this way, you have the possibility to compare within groups. In the parallel study, you could compare only between groups, the therapy and control groups. Here, you can control the same group, the same people, taking medication A and taking medication B. And or in the outcome variable between when they were using the medication A and they used the medication B. Do you understand the difference between parallel and crossover study?
Mister, can you give example of cross-sectional?
Example about what?
About cross-section studies.
Crossover. This is
Crossover, yes. Yes,
crossover
crossover.
study. Yeah. I have tried to give you an example, but let us do another example, okay? You have a sample. The sample you divide into two groups, okay? What do you want to study? What do you want to measure from the body?
Okay, for example, glucose level.
Glucose level, blood glucose, okay? Glucose, fasting blood glucose. You want to measure fasting blood glucose. We measure it in the beginning. We have our individuals here. Then we have two medications we want to compare, or two methods of treatment. Medication A and medication B. Okay? You administer them. After some time, you measure again fasting blood glucose. Okay? You measure fasting blood glucose also in this group. Measure the fasting blood glucose and you compare whether there is a difference between these two measurements. But this is a parallel study. But then you wait for some time, washout we call it, washout. You wait for some time, okay? You wait for some time and then you give this group the medication B. And you make another measurement of fasting blood glucose. This group receives, in this case, the medication A. And you measure the fasting blood glucose again, also in this group. So this is allowing you to compare within groups, within group comparison. Here we compared the between groups, The group A and B, you compare the fasted blood glucose. This is between groups. You know that the variability in between groups is larger than the within groups. That's our issue here, the problem here. You want to decrease the variation. The one way to decrease the variation is to have a crossover design. If you have a crossover design, you give a medication A to the person, measure the outcome, wait for some time, washout period, then you administer the medication B in this case, to the same people, and repeat your measure. That's a crossover study design. Of course, you are smart people. You should have some questions concerning the crossover studies. The crossover studies cannot be applied in any situation. You can do it only if the condition is chronic, isn't it? It should be, it's only applicable, only possible where in chronic diseases. In chronic diseases. What kind of chronic diseases do you know? Hypertension, diabetes. What else? Can you count some chronic diseases for me, please?
Histofibrosis.
Tuberculosis.
Tuberculosis, is it a chronic disease, tuberculosis? I'm not sure. Yeah, it takes long time, but at the end, it's an infectious disease, which is, once you have given the medication A, it is treated, it is gone. There is a possibility, it takes long time to treat tuberculosis patients, but it improves. So when it's time to give medication B, there is no disease anymore. Okay.
Cancer.
Also, the cancer
Alzheimer.
it can improve.
Diabetes.
Diabetes, hypertension, we already mentioned.
HIV.
Okay, Alzheimer.
HIV, what?
Alzheimer's.
Alzheimer, very good. Okay, Alzheimer.
AIDS.
AIDS, maybe, yes, AIDS. Okay, so the COPD, chronic obstructive pulmonary disease.
Arthritis.
Asthma, arthritis, very good, arthritis, osteoarthritis, especially osteoarthritis. So these are diseases which usually migraine, chronic migraine. But for example, infectious diseases, flu, viral or bacterial, doesn't matter, or fungal, infectious diseases, you cannot apply this methodology. If you have sore throat, let's say, and you give medication A, antibiotic A to one group and antibiotic B to the other group, and measure the outcome, the pain level or something, and then it is gone, it is finished. The patient is treated. There is no possibility anymore to make a washout and administer drug B. For what purpose you will give drug B? It is already treated, the condition. So it has to be, of course, naturally, it has to be chronic diseases. Okay, I hope you understood crossover designs. The other study design, special particular study design, is the factorial experiments. The other particular design is factorial experiments. Factorial. In the book, they mentioned about, the authors mentioned about aspirin and beta carotene in treating heart conditions for heart patients. We may give another example to make it, two examples will make it easier for you to understand. Remember the tests, how we select the tests, hypothesis tests in biostatistics. I told you, you should have first decide whether you have a numerical or categorical outcome variable, and then you ask yourself, do I have one group, two groups, or more than two groups? Always the same, one group, two groups, more than two groups, comparing one outcome variable. So my example here is hypertension. You want to treat hypertension, and you want to compare drug A and drug B, okay? And you want to see the effects of what two medications on decreasing the systolic blood pressure. But actually, medications are important in decreasing blood pressure, but there are other factors affecting blood pressure. For example, what? Is it only the medication you are taking which will decrease your blood pressure? Is there any other method to decrease the blood pressure?
Yes, I guess.
What, for example? You are going to become a doctor. You are going to become doctors. Patient may ask you, okay, doctor, you give me this medication, but is there anything else I can do to decrease my blood pressure, to control my blood pressure?
Yes, sir.
Exercise.
Reducing salt consumption.
Sorry, repeat, please.
Reducing salt consumption.
Salt consumption. Very good. Yeah.
Exercise.
Salt. Very good. Exercise.
Proper sleep.
Proper sleep. Okay. Excellent. So a lifestyle, let's call it lifestyle, maybe.
Yes, sir.
Such as sleep. Yeah, you can increase this, and you already mentioned the most important things, but there are more, of course. Not only salt, also potassium is important. Huh?
Yes, sir.
Potassium is also important for controlling blood pressure. So there is not only one factor that's affecting your outcome. There are more factors. There is people with hypertension taking drug A and exercising. Exercise positive. Let's call it X positive and X negative. X negative. And you have people taking drug B and exercising. Exercise positive and exercise negative. Okay? And you can increase these combinations. Huh? You can have people taking drug B, exercising, and consuming salt positive, and salt negative, and so on. The factors affecting your outcome, the blood pressure, are not limited to only the medications you are giving. They are more than this. The question in life is not that much easy to answer. Usually there are more than one factor affecting the outcome. Therefore, in medical research, we prefer to have factorial experiments. In a factorial design, here we have two factors, aspirin and beta carotene, but even it could be for the heart diseases, there could be more than two factors affecting your outcome. So if you have a factorial design, you may control for the variation as well. Okay. My last point in this session is about the endpoint, study endpoint, and which is not directly related with the variation. Therefore, I should go to a PubMed and make a search. Let us search about the primary outcome measure. I will search the PubMed for primary outcome measure. I have, as you see, 6,000 results and free full text. I have selected free full text. Okay. The primary outcome measure in primary outcome measures, intervention trials, fractures, dignity impact, back pain trials using clinicals, posterior teeth. Oh, posterior. What is new in pain modification in osteoarthritis? Okay, osteoarthritis. Where do we have primary outcome measure? You see, if you are studying osteoarthritis and you want to compare groups, usually your outcome would be the pain. Pain in osteoarthritis is the primary outcome measure. As you see in this study, they mentioned about something called the primary outcome measure. In our book, it is mentioned as the study endpoint. So endpoint, I should write it down so that you may remember. Okay, let us clear this screen. So in any study, you have study endpoints. Study endpoints. Which is equal to outcome. Or equal to primary, as I mentioned here, primary outcome. As I searched the PubMed, I searched it for primary outcome measure. I could also write primary outcome only, primary outcome. I would have maybe more results, of course. Primary outcome is also used as a terminology, primary outcome, or main outcome. Or outcome, or simply outcome, or primary outcome. Okay, so study endpoint, outcome. If there is something else coming to my mind, I will mention it. Don't worry. So before any data, any studies starting, you have to decide on your endpoint. And this you already know. Huh? This you know from the really beginning of this course, that we have the PICO format, the PICO acronym, where the O stands for outcome. So instead of outcome, we could say endpoint, we could say main outcome, primary outcome, doesn't matter. It is outcome. This is the same. It is meaning the same. Okay. It should relate to the relevant hypothesis you are studying. Yes. Okay. So that much is enough, I think. Yes. Everything. The test, the sample size, your sample size, your study design, the tests you are going to use in the analysis, everything is depending, based on this outcome. Therefore, in the beginning of any study, we have to make sure, ask ourselves, what is the outcome, the primary outcome? There may be more than one outcome in a study, but we should select the primary, the essential outcome of our study. We should decide, we should write down what is the main outcome, the primary outcome of my research. Yeah, that's all for today, folks. Next week, we will continue with something else, namely what?
Clinical trials.
Clinical studies and cohort studies, yeah. So this is already, we mentioned about them just briefly, clinical studies and cohort studies, what they are, but next week we will, inshallah, hopefully go into more details.